Okay, so when I find the second derivative implicitly, well, I'm just going to start with a function like this. And first thing I have to do is find what? If I want to find the second derivative, what do I need to find? I need to find the first derivative. Okay, this is just a function, it's not a derivative. So, all right, so what's the derivative of x squared? 2x. Plus, what's the derivative of y squared? 2y times y prime equals the derivative of 36, which is 0. Okay, so now let's get y prime alone. Tell me what? Subtract 2x, so I have 2y times y prime equals negative 2x. What next? Divide by 2y. And I get y prime equals, ooh, what's going to cancel there? Those 2's are. So y prime is negative x over y. So there's my first derivative. And I want to circle that because I am going to need it later. I'm going to need this. I need it to take the second derivative, but I'm also going to need it later after I take the second derivative. So now let's work on taking the second derivative. So here, now, this has y prime by itself. So the second derivative, the derivative of this, is the derivative of y prime is what? Y prime prime equals, so how am I going to take this derivative now? Quotient rule. Now I'm going to use the quotient rule. The quotient rule. So I take the bottom, which is, what's the bottom? Y. Y is the bottom. Times the derivative of negative x, negative 1. Minus the top, which is negative x, times, what is the derivative of y? Y prime. All over, where's y squared? The only time I multiply by y prime is when I take the derivative of y. Okay, so now, what seems weird about this? Alejandro, what?
There's that one extra y prime.
Okay, I've got a y prime sitting in my y prime prime. I've got a first derivative inside my second derivative. So that's why you needed to remember what the first derivative is. Because now I can just say, well, I already know what y prime is, because I don't want a y prime within my second derivative. So all I have to do, I'm going to replace this with negative x over y. So I'm going to kind of clean the step up a little bit too. So y times negative 1, how should I write that? Negative y. And how should I write this? Well, just that part. Plus x. And then I'm replacing the y prime with negative x over y. And that whole thing is over y squared. Okay, now, can I leave it like this? You would like to leave it like this, but why can't you leave it like this? Fraction in a fraction. So what can I multiply the top and the bottom by to get rid of that fraction? Why? What's causing the problem here? What's on the bottom? Y. Multiply the top and bottom by y. So if I multiply the top by y, what property do I have to use? Distributive. What's y times negative y? Negative y squared. And what's y times that whole mess right there? Multiply those. What cancels? The y's cancel, and I have what? Minus x squared. See how that worked out nice? Top has no more fractions. And what's on the bottom now? Y cubed. And I'm done. Don't even try. Don't even think about it. Some of you were. You were thinking about canceling. Don't, because there's subtraction. Okay, do you want to see one more of those or go to the board? Yes, Carissa. Okay, you know what, Carissa? I like that you answered that question, asked that question, and we're going to go there. Carissa says, can't you just do this? Can't you just say, can't I just get y by itself here? Is that really hard to do? How would I get y by itself? Subtract by what? X squared. So y squared would equal 36 minus x squared, and then what? Square root both sides. And when you square root both sides, you're going to have a positive and a negative, right? So you actually, by getting y by itself, you have two functions to find the derivative of. But Are the derivatives harder? I mean, aren't they the same derivative, one positive, one negative? So could I go ahead and just find the derivative of this? Yeah, let's do that. So y prime would equal, what rule am I going to have to use here to find this derivative? Chain. What's the outside? Something to the, not, something to what power? The 1/2 power. And the inside? 36 minus x squared. So y prime would be 1/2 times 36 minus x squared to what power? Negative half. Times the derivative of 36 minus x squared? Negative 2x. So y prime cleaned up a little bit. What would be on top? No. Half of 2. What happens to the 2 and the half? They cancel. You get negative x, and on the bottom you're going to have 36 minus x squared to the 1/2 power. Okay, now we have to take second derivative, right? Are you ready? You ready for the second derivative? Okay, I'm going to rewrite the first derivative on the next page. Actually, it's a good thing Chris asked about this because one of your homework problems asks you to do it both ways. Like find the derivative this way and implicitly. So y prime is negative x over 36 minus x squared to the 1/2 power. How am I going to take the second derivative? Quotient. Quotient. And what part of that quotient is going to have the chain? The bottom. In fact, didn't I just take the derivative of that when I took the first derivative? Okay. So quotient rule, y prime prime is going to be the bottom times the derivative of the top, which is, can I just write a negative in front of that then? Minus the top, which will make it plus x, times, we already took this derivative, didn't we? Didn't we already take the derivative of that? And isn't it this? If you don't believe, we'll do it again. Okay, what's the derivative of the bottom? You don't believe me. Okay, so the derivative of this, the derivative of the outside is 1/2 times 36 minus x squared to the negative 1/2 times the derivative of 36 minus x squared, which is negative 2x. Okay, so that's the derivative, the bottom times the derivative of the top minus the top times the derivative of the bottom, all over. What happens if you square that? What do you get? 36 minus x squared. Okay, so let's clean this up. Y prime prime is negative 36 minus x squared to the 1/2 power. And here, what's on the top of that part? Negative x squared. And on the bottom I have 36 minus x squared to the 1/2 power. All over that. So what should I multiply top and bottom by? Top and bottom by the problem up here, which is, 36 minus x squared to the 1/2. Okay, so y prime prime is, if I distribute this times this, a square root times itself. Negative quantity 36 minus x squared. And then this times this, minus x squared. And the power on the bottom, 36 minus x squared to what power? 1 plus 1/2. 3/2. So finally, y prime prime is, if I distribute this negative, you get negative 36 on the top, and you get 36 minus x squared to the 3/2 power on the bottom. That's the second derivative we got doing it by getting y by itself. What is the second derivative we got the first time? Negative y squared minus x squared over y cubed. How are those the same? How are those the same? Are they the same? Shouldn't they be the same? Maybe you're lost. Maybe you don't remember what we were doing. Let's back up. Remember we started by taking this derivative. We found the second derivative of this implicitly, and we got this. And then Carissa said, well, couldn't I have just gotten y by itself and found the second derivative? And I said, sure, yeah. So we did it, and we got that. Didn't we take the second derivative of the same function two different ways? Shouldn't these be the same? My question is, should these be the same, yes or no? Yes, they should be. If you took the second derivative of the same function, they should be the same. So we need to see how on earth is negative 36, here's y prime prime. This is a good question. Some of you are like, oh, I don't like this stuff. But this is good. This is real math. Okay? How is this going to look like this? What was back up here, here's the original function, x squared plus y squared equals 36. What could I replace the y squared with? Or, I have another question. What could I replace negative 36 with? Let's look over here. See, when you're doing a proof, this is a proof right now. I'm trying to show that this and this are the same. And all I have to use is my original function. Because that is the one thing they shared in common. So can I make this side look like this side? Or this side look like this side? Or mix them both up until they look the same? Okay, I just can't move things from side to side. That's what I can't do in a proof. So negative 36, what would negative 36 equal? Negative y squared minus x squared. Why did I write it like that? Because that's the way it's written on the other side. So using 36, my original equation, making it everything negative, I can rewrite this like this. Okay? So now, what is this? What does this equal? If I take y squared, doesn't that equal 36 minus x squared? So couldn't I make the bottom y squared to the 3/2 power? And what do you do with double exponents? You multiply them, and 2 times 3/2 is? You struggling with 2 times 3/2? 2 over 1 times 3 over 2. It's 3. Does this now look exactly like the other derivative? We just showed that both our derivatives are the same. So, okay, that's a little above and beyond, but that was good stuff there.